This is Mrs. Struble with Struble Math, and in this video we're going to be discussing the order of operations and the basic properties of numbers. So let's get started. The order of operations are a set of steps that tell us how to perform math steps within an expression. Oftentimes, this is taught as a simple phrase to help us remember the steps. Please excuse my dear Aunt Sally. But let's dive into what those actually mean. The P stands for parentheses or other grouping symbols. So our first step would be to perform operations within grouping symbols. If there are multiple grouping symbols, we have to work from the innermost grouping symbol first. Step 2 is to evaluate powers. So we're going to evaluate those exponents or simplify them to their lowest possible setting. Next, my dear, multiplication and division. We're going to do these from left to right. It does not matter if multiplication is first or if division is first. We are going from left to right as if we're reading a book, and we're applying multiplication and or division, whatever comes our way. And finally, we'll add and subtract the same way in which we multiplied and divide to find a simplified result. Let's try this using some examples. In this first example, we have the operations of subtraction and division. Using our order of operations, which we just learned, PEMDAS, we do not have any parentheses nor exponents, so we can go ahead and skip those steps. I do see, however, multiplication or division. In this case, it's division. So we're going to do the division of this expression first, which is 18 divided by 6. Okay. After a step is completed, we have to realize that we just used two numbers and one operation. So everything else in that expression is still present. So it does what I like to say, fall down. So it falls down. And now we are left with 27 minus 3. We have some subtraction, so we're going to do that. And we get 24 as our final result. In number 2, it's a little bit more complex as we go here. So let's just continue to use our order of operations, one thing at a time. We still have no parentheses, so we're going to go ahead and skip that step. We do not have any exponents, so we'll skip that. We do, however, see multiplication and division both present in this. The division and the multiplication are within those lines here that I drew. Okay, we're going to do this from left to right like we're reading a book. So we're literally starting with this 18. We're dividing by 2 to get 9. Once we do that, however, because we can only do one operation at a time, we have to remember, hey, that multiplication is still there. So we're going to take 9 times 3 to get 27. And everything else falls down. You'll have to forgive my handwriting on this one. I seem to have misplaced my normal stylus here. All right, multiplication and division are now complete. We're going to finish this up by completing all the addition and subtraction once again from left to right, like we're reading a book. So 36 minus 27 comes next. And 36 minus 27, you'll get 9. And then we add 8 to get an answer of 17. Number 3, same thing, PEMDAS, go ahead and start up there. We do not have any parentheses, but we do see, however, exponents, so we're going to take care of those exponents right away. 6 squared is the same thing as saying 6 times 6. There are 2 6s being multiplied together. That results in 36. Everything else falls down. So we got the 5 and the plus sign over here. We got the multiplication and the 10. Okay? Everything that we did not use, we need to just drop down. And then we go ahead to our next step, which is looking at any multiplication or division. We spot multiplication. 36 times 10. That's an easy one. There you go. 360. Everything else falls down. So that 5 plus. And then we, last step, do that addition and subtraction. So we have 5 plus 360. 365. Here we go. There's 2 over here. I'm going to go ahead and write PEMDAS to the other side. And we'll use that. Just kind of a reminder of our steps. The first thing we need to look for is parentheses. Now we do have parentheses. When it says parentheses, what it needs us to do is find one value embedded within those parentheses. So I need to make 2 times 6 only one value, which is 12. Okay. Everything else falls down. See some subtraction and some division. So no exponents. Parentheses are gone. Let's do that division. 12 divided by 3 is 4. Keep going. 36 minus 4. We get 32. All right, last one. Okay. Notice we have 2 sets of parentheses. Okay. Earlier I had stated when we see this, we need to work within the innermost parentheses first. So we're not going to look at the brackets yet. We're going to start with the regular parentheses. We're going to go inside those, and we need to make that statement one value. So we have 4 plus 12 divided by 4. Within this statement, we still have to use our order of operations. Okay, so there are no more parentheses because we're working within the parentheses. Exponents, no exponents. Multiplication and division comes first then. So we're going to do the 12 divided by 4 first to get 3. The 4 plus is still there. We still are not at one value, so we keep going. We get the 4 plus 3, which is 7. 7 is that value within those parentheses. Okay. Now that we have one value within the parentheses, we are done with that set. Everything else is falling down. That's what I'm doing here, including the brackets. And now we are going to work within the brackets. And within the brackets, we have 7. Don't need those parentheses no more in this case. Minus 2, which is 5. Now we have one value out inside of the brackets. So we are done with any grouping symbols. Okay. Don't forget that cube. Let's go ahead and drop that down so we don't forget. Okay. Next step is exponents. Well, that's really all that's left in this one after we've completed everything else. So this says 5 cubed. In other words, there's 5 times 5 times 5. 3 5s all multiplied together. 5 times 5, 25. Notice how I'm doing it from left to right. This is a multiplication. And then we have 25 times 5, which is 125. Let's see how this concept or skill would work given a word problem. Maria works part-time in a law office where she earns $20 per hour. The table shows the number of hours she worked last week. Simplify the expression, the quantity 6 plus 5 times 3 times 20, to find out how much money Maria earned last week. We're not at this point yet, but we will have to get to a point where we take the given information, in this case the table, and create the expression on our own. So let's take a look at the table. We got 4 days, 6 hours on Monday, 5 hours on Tuesday, Wednesday, and Thursday, and see where they might have come up with the numbers in the expression given. Well, 6 is the hours worked on Monday. There are 3 5-hour days. Hence, the 5 times 3. For each hour Maria works, she gets $20. So we'll add all of the hours, which is expressed in the parentheses here, and multiply by 20. Thankfully, in this word problem, they gave us the expression, and we just simply have to evaluate it or solve it. Okay. Using PEMDAS, we see parentheses right away. We're going to work within those parentheses to figure out how many total hours she worked that week. Looking within those parentheses, 6 plus 5 times 3. Let's go ahead and do the multiplication first. 5 times 3 and get 15. Everything else is still there. So we're going to do the 6 plus 15. So we're going to add 6 now and get a total of 21 hours. Multiply that by 20 is our last thing that we need to do to find out that Maria will have earned $420 that week. Several examples of how to incorporate the algorithm known as PEMDAS to help us with our order of operations and evaluating expressions. Now, let's take a look at some basic properties of understanding with numbers. These properties help us understand that one way isn't always the only way. And that's one of the beautiful things in math. The properties that we're going to talk about here are what's known as the commutative property, the associative property, the distributive property, and the identity property. Please remember you can feel free to pause the video at any time so that you can take notes as needed. The commutative property tells us that, hey, sometimes the order just does not matter. If I have 5 plus 2, I know my answer will be 7. If I reorder that and I put the 2 first, I still get 7. That's what the commutative property is all about. Here's how I like to remember it. To commute means to move about. Okay? So if all we're doing is adding, we can rearrange the numbers, we can move them around, and we still get the same result. The same thing applies for multiplication. I can move those numbers around as long as I am only multiplying. It doesn't matter which order I put them in. 5 times 2 is still the same thing as 2 times 5. They commute, they move, and they still get to the same place. The associative property. To associate means to talk or to communicate with each other. So essentially, it doesn't matter which numbers are communicating or associating with each other first, as long as there is only addition or only multiplication, I can multiply or add whatever 2 numbers first that I want. Distributive property. Well, again, let's take a look at that root word, to distribute. To distribute means to hand out equally. Okay? So when a teacher is passing out papers, each student gets that paper. Some students might get that paper first, some students might get that paper last, but everybody ends up getting the paper. The same thing applies when we are using parentheses and we have a value right next to it on the outer side of those parentheses. Now that value could be to the immediate left of those parentheses. It could be to the immediate right of those parentheses. I want you to understand that. But inside those parentheses might be some other numbers. Yes, the order of operations say, hey, look inside those parentheses, do 4 plus 1, and then use multiplication times that by 9. But there is another way. I can use the 9 and say this is the same thing as if I did 9 times 1, and then I added 9 times 4. So essentially, I am handing out or distributing that multiplication of 9 to everything inside that parentheses, the 1 and the 4 in this case. Oops. Obviously, this might be more work in this example, but this knowledge comes in handy when we are trying to do math mentally and very fast. It also comes in handy in our higher leveled math, algebra problems when there is a missing value, and you will see that as well. Lastly, the identity property. The identity property is simply saying that, hey, we can do something to a number without changing it. When we're talking about adding, we can add 0. Yes, I know that sounds crazy, but it does come in handy knowing that any number plus 0 is that number. The same thing goes for multiplication. Any number times 1 is that value back in your face. So again, seems weird. Why would we ever want to do that? It comes in handy when we're doing higher leveled algebra problems. Okay. All right. Let's look through these problems. Hopefully you had enough time to copy those down on your own. Okay. First things first, we got to learn how to identify the properties. Big hint right here in number 1, the numbers are all in the same order. The parentheses are just moved. Okay. Instead of the 7 and 8 being grouped together, it's the 2 and 7. So which property says that it doesn't matter which 2 numbers talk first? That's the associative property. Number 2 here, 25 times 1 is 25. Well, we're doing something to 25 and we get 25 back in the face. Okay, so it doesn't change its identity. Now, xy equals yx. Now, if you don't know, when a letter is right next to something and there's no symbol, that's just a shorthand for the operation of multiplication. So this is essentially saying x times y equals y times x. Okay. The values switched spots. We're using multiplication, and we know that's not going to change the results, so they're going to be equal to each other. What is that when we switch the values or we move them about? Commutative property. Taking a look at questions 4 and 5, the directions say to simplify each expression and justify each step, but it doesn't tell you how to simplify. So yes, we have order of operations we've got to follow, but we've also just learned that in the event that all we have is addition or all we have is multiplication, we can make it faster for ourselves in different ways. So taking a look at number 4, 12 plus 19 plus 18. I don't have to do 12 plus 19 first. If I see something that's easier to add, I can add those 2 numbers first and then add the third number. Okay? So, in other words, what I see right now, right almost immediately, is 12 and 18. Well, 2 and 8 equal 10, so 12 and 18 is 30. I want to add those numbers first, just to make it easier on myself. This comes in handy when you have a whole bunch of numbers that you're adding together. And rather than using your fingers or trying to think, oh my gosh, 12 plus 19, that's 31, but what's 31 plus 18? If you group them up into units of 5 or 10, into those quantities, then it's a lot easier. Okay, so what we're going to do in this one is we're going to do 12 plus 18 first, get 30, and then say 30 plus 19, well, 49. Okay, it's just a little easier on ourselves. Now, the justification of that, What justifies the fact that I can do 12 plus 18 first, and I don't have to do the 19 plus 12 first? I can reorder this and put the 18 first if I want. What property says I can move these numbers? The commutative property, okay? So my justification is, hey, I use the commutative property to get the answer faster, right? All right, let's take a look at 5. Again, I'm looking at 25 times 13 times 4. Yikes. I don't want to have to spend too much time on a simple problem like this. I like 25 because 25 reminds me of quarters. And then I see this 4, and I know how much 4 quarters are equal to. Well, 4 quarters are equal to 100. So that is what I want to do first. I want to do the 5 times 4. So I'm going to move the 4 over next to the 25, and I'm going to say I can reorder this, and I can put it as 25 times 4 times 13, so that I can do the 25 times 4 first. I'm going to do this all in my head to make it faster. Well, 25 times 4 is 100, and 100 times 13, well, just add 2 zeros because it's a multiplication, it's a power of 10. So we got that little trick for us, and we get 1300. What told me that I could move the 4 right next, or I could do 25 times 4 first? Once again, I used the commutative property. Is that the only property that could have been used? Absolutely not. But in situations like this one, I just find it the easiest. All right, guys. The last thing I want to talk about, it has to deal with that distributive property. If you recall, I said that the distributive property plays a very important role when it comes to higher level math, such as algebra. I want us to look at this distributive property a little bit further. And how does it work? We use the distributive property, we can use the distributive property to help us do mental math also. Okay? So again, no algebra here yet. We're just working with the numbers, and we're realizing something about the distributive property and how it can help us do math faster. So if I have, for example, this 7 times 29, okay, and I want to do this fast. I can think of this as 7 times 20 plus 7 times 9. Now, I might not know 7 times 29, but I know right away, working with powers of 10 here, that 7 times 20 is 140, okay? Because really I'm just putting 14 and adding a 0. And also know that 7 times 9 is 63 because I know my simple facts. So I can take 140 plus 63, and I can get the answer of 203 really fast. Another way to look at this is, well, 29 is really close to 30. I like my powers of 10. Or, excuse me, not powers. I like my multiples of 10. Okay? So I'm going to say, well, all right, 7 times 29 is really 7 times 30 minus 7. Okay? So 7 times 30, well, 7 times 3 is 21, so that's 210. Subtract 7, well, 10 minus 7 is 203. Either way, we get the same result quicker than anyone else who's trying to write this down, as long as they're not using a calculator. Anyone trying to write this down is doing, okay? I can do it mentally without having to necessarily write all the steps down. So, in this video, we worked with our order of operations and properties of numbers. We used those order of operations to simplify numerical expressions. We also used our properties, worked with them to identify those properties, and used them to simplify numerical expressions. Thank you for joining me. This is Mrs. Struble with Struble Math. See you next time.